Hey y'all, I wanted to make a video documenting my Z80 8-bit computer. It's pretty messy right now. It's on a breadboard, as you can see, and all these jumper wires are pretty insane, but hopefully in the next few weeks I'll be moving this to a prototyping board, and I'll also be wiring up this UART chip, which I'll talk about in just a second. So right here we have the Z80 microprocessor. This is the 10 megahertz version. Right here is a Atmel AT28C64B. It has 64 kilobytes of electronically erasable programmable read-only memory, EEPROM. And right here we have 256 kilobytes of SRAM by Alliance. Though the Z80 can only address 64 kilobytes of memory in total, so it's addressing 8 kilobytes of ROM and 56 kilobytes of RAM. Right here is just a standard 74HC32 quad dual input OR gate chip, and right here is a 74HC04 hex inverter, which is used for the reset circuit, as well as in conjunction with this quad OR gate chip is the address decoding for the memory. Right here, I'm using this octal tri-state buffer as an I/O device to control these 8 LEDs. Right here is the least significant bit to the most significant bit. Right here is a UART chip, a universal asynchronous receiver transmitter, which isn't wired up yet, but it will be in hopefully the next 2 weeks. And this basically allows me just to communicate via RS-232 to my desktop computer, which my desktop computer will act as a dummy terminal, and I can send and receive data through this RS-232 to USB. To drive the UART, I'm using this 1.8432 megahertz crystal, which will run the UART at 9600 baud. And since RS-232 runs at 12 volts instead of the standard TTL levels of 5 volts, I'm using this Max 232 to provide the 12 volts for that. Yeah, so that's the overview of the computer in its current state. Oh, actually, right here I have a 10 megahertz crystal that'll run the Z80 at 10 megahertz, but this simple program I have, this test program, would be done in less than a fraction of a second. So I'm using this Arduino with a simple Blink program running at 1 kilohertz to run the program. So what this program does in here is it starts with the A registers at 0, and it points the HL 16-bit registers at memory address F000. And it'll run through a loop 255 times using the D, J, and Z loop, where it'll start B at 255 and decrement once, and jump back to the beginning of the first loop. So what it's going to do is write A to whatever memory address HL is pointing at, and then it'll increment A, and then it'll increment HL. So A will now be 1, HL will be pointing at F001, it'll write 1 to F001, increment both, it'll write 2 to F002, all the way up to writing 255 at F0FF, or F0FE. And yeah, so that's just the program. Oh, and then it'll read, starting at F0FE, it'll just read out the data, and it'll decrement HL. So it'll display 255 on here, it'll decrement HL, then it'll display 254. So it'll pretty much just count down. Starting at FF, it'll count down to 0. So let's go ahead and look at that program here. I have this reset button. It'll show the LED, press and reset. And nothing's going to happen for a while, just because the processor right now is filling those 255 bytes of RAM. So nothing's going to happen, and then all of a sudden all these LEDs are going to start freaking out. But they blink pretty rapidly because I'm using a tri-state buffer in the I/O request. The I/O request only happens for one fraction of an instruction, because the instruction cycle of the Z80 is actually 4 instructions long, and the I/O pin's only the I/O pin's only low, is the active low, for 1 cycle, so it's pretty quick. But you can kind of see it's counting down in binary, and there's the end of the program. Now if I put this 10 megahertz crystal in, you'll see the program finishes incredibly quickly, of course. So you just saw it run at 1 kilohertz. Now it's going to run 10,000 times quicker. And you're not going to see much. The LEDs just barely flash because they can't even keep up with 10 megahertz signal. And yeah, that's the program running at 10 megahertz. So that's about it. It was just a simple test program to test the capabilities of RAM, the processor, the ROM, and the I/O device, just to make sure that everything, all the components are working, the address decoding is working, and that it's reading and writing to all devices correctly. So anyways, that's the first progress video. I'll be hopefully uploading another one in which I have the UART working, and I really do want to transfer this to a prototyping board. I already ordered some, and hopefully it'll be here by this weekend, and I might just start soldering to the prototyping board. So anyways, thank y'all for watching, and we'll see you around next time.